So good morning students. Today we are discussing topics 8th class. So thermal properties of matter. Already we discussed in the first video. There are some conceptual questions and single correct answer type questions. So there are some other questions which are related with level 2, that is multi correct answer type questions. Multi correct answer type questions. See, in the thermal properties of matter, it's more than one correct answer we are going to discuss now. See, the question number 20 here. Identify the correct statements from the following. Identify the correct statements from the following. The first statement is here. The apparent expansion of a liquid depends upon the expansion of the container. So, second option B, the real expansion of the liquid depends upon the density of the liquid. And option C, the expansion of the liquid is respect to the container is called apparent expansion. And the fourth statement, the expansion of water is uniform. See here, the first three statements are true here. The first three statements are true. See, the apparent expansion of the liquid depends upon the density. Depends upon the expansion of the container. And the real expansion of the liquid depends upon the density. The real expansion of the liquid depends upon the density, and the expansion of the liquid with respect to the container is called, the expansion of the liquid with respect to the container is called, so that we will call it as the apparent expansion. The fourth statement, the expansion of water is uniform. Expansion of water is not uniform. 0 to 4 degrees centigrade strange behavior of water will be there. That's why this is the fourth statement, the false statement. So the option A, B, C are the correct for this question. So the next question, the apparent expansion of the liquid depends upon dash. The apparent expansion of the liquid depends upon dash. Here the nature of the liquid, option A, nature of vessel, scale of temperature, density of the liquid. See, the given options, if you observe, the yes. See, in the given options, see the nature of the liquid, nature of the vessel and scale of temperature. These are the three correct answers. The A, B, C are the correct answers for this question. Coming to the next question, a liquid of coefficient of real expansion is gamma. Actually here the liquid of coefficient of real expansion is gamma. This is not G, it is gamma. Gamma is partly filled. See, of coefficient of linear expansion, gamma by 3. Coefficient of linear expansion, gamma by 3. So when the system is heated, then what are the options are correct? When the system is heated, see, if you observe carefully, the liquid of coefficient of expansion is gamma. Then the container expansion is also here alpha is equal to gamma by 3. Alpha is equal to gamma by 3. Hence container expansion is nothing but 3 alpha. So 3 into gamma by 3. 3 into gamma by 3. It means that it is also gamma. So the liquid expansion is gamma and the container expansion is gamma. That's why if you observe carefully, the given statement, the level of the liquid relative to the vessel is remains the same. This option is correct. The fraction of the volume of the liquid vessel remains the same. These two options are correct. The remaining two options, the volume will be, see, volume, there is no correct answer. The temperature of the liquid and vessel remains, it is also not correct. Only option B and C are correct. Why? Because both are, the liquid and as well as container has the same coefficient of linear expansion. That's why option B and C are correct for this question. So coming to the next question, pick up the pick out the correct statement from the following. Pick out the correct statement from the following. If you observe, yes, the statements are, what are the statements are there? Water is taken up to a brim of the container of negligible expansion at, see, the brim of a container of negligible expansion at 4 degrees centigrade. When it is heated or cooled, see, the water overflows. Water will be overflows. Means water is taken up to the top of the container, brim of the container. So when it is gets heated or cooled, there is a expansion will take place. Due to that, water will be so coming out of that. That is the first option. Second, silver iodide exhibits anomalous expansion. Anomalous expansion. Rubber exhibits anomalous expansion. Fourth statement, all polar liquids exhibit anomalous expansion. If you observe here, the statement A is correct and statement B is correct. Silver iodide, see, which has got anomalous expansion. See, rubber do not have any anomalous expansion, and all polar liquids also do not have any anomalous expansion. It means option A and B are the correct. See, water has strange behavior from 0 to 4 degrees. That's why, okay, so water gets, okay, so whenever it is there, it will be overflows 0 to 4 degrees centigrade. So option A and B are the correct options. And polar liquids are nothing but the liquids having positive as well as positive, either positive or negative charge. Those are called polar liquids. A small explanation is there here. The polar molecules, water, H2O, and the polar molecules like ethanol, ammonia, these are sulfur dioxide. So these are the polar molecules. Polar and non-polar, if you observe, positive, negative. So these are the explanations for the polar molecules. Coming to the next question, 24th one. The 24th question, during the heat exchange, the temperature of the solid, during the heat exchange, see, the temperature of the solid mass does not change in this process. See, if you observe carefully, option A is not being supplied to the mass. This is the wrong statement. Definitely heat is going to supply to the mass. And option B is not being taken out of the mass. That is also not correct. So then C and D may have been supplied to the mass. Okay, so may have been supplied to the mass or may have been taken out of the mass. Okay, the heat may have been taken out of the mass. So that's why C and D are the correct options for this question. See, next question. Yeah. Comprehension passage type questions. These are comprehension passage type. There will be a paragraph will be given. Some questions are, so those questions you have to answer it. So the passage is here, the apparent expansion is equal to mass of the liquid expelled by mass of the remaining liquid into rise in temperature. So this is the simple passage data what it is given. See, in this question, 25th question, a vessel contains 105 grams of liquid. A vessel contains 105 grams of liquid at 0 degrees centigrade. The vessel is heated to 100 degrees centigrade. When 5 grams of liquid is expelled, then the coefficient of real expansion. See, 5 grams of liquid is expanded. So then coefficient of real expansion should be find out. See, to find out this, see, coefficient of real expansion is equal to, what is the formula? Coefficient of real expansion is equal to coefficient of apparent expansion plus coefficient of container expansion. Coefficient of container expansion, that is gamma G. Here there is some data is missing. Here alpha value should be given. Alpha is 9 into 10 power minus 6 per degree centigrade. This data is missing in the question. See how to take this. If you know alpha, you can find out gamma G. See, gamma G is equal to 3 alpha. So 3 into 9, 27 into 10 power minus 4 minus 6 per degree centigrade. It means 0.27 into 10 power minus 4 per degree centigrade. So 0.27 into 10 power minus 4 per degree centigrade. So here the gamma A can be find out. Apparent expansion is nothing but the mass of liquid expelled. Mass of liquid expelled it is 5 grams upon, see, original mass of the liquid 105 minus 5, that is 100. So change in temperature, that is again 100. It means you are going to get here 5 into 10 power minus 4 per degree centigrade. Once if you know gamma A and gamma G, gamma A is apparent expansion, gamma G is the container expansion. Then real expansion of the liquid is equal to, so gamma A plus gamma G. Gamma A is 5 into 10 power minus 4 plus, so 0.27 into 10 power minus 4. So if you simplify this, 5.27 into 10 power minus 4 per degree centigrade. 5.27 into 10 power minus 4 per degree centigrade. So this is about the answer. Option A is correct. In the given options, 5.27 into 10 power minus 4. See, the remaining options are wrong. Okay, so that's why option A is correct. So this is the simple explanation. So in the next slide, that only change in volume. See, mass of liquid expelled, the same thing. See, instead of G here, gamma G is supposed to be there. See, gamma G, it is supposed to be there. Here there are some small changes. Gamma A is correct. Here this is gamma A. Again here gamma G. This is 3 alpha. Again gamma R is equal to gamma A plus gamma G. The same thing what it is explained here. What just now in the previous slide what I explained. So coming to the next problem. In an experiment with the specific gravity bottle, the mass of the liquid is here. The mass of the liquid is expelled 1 by 50th gram, 1 by 50th of the mass of the liquid remains for the temperature difference of 20 degrees centigrade. Temperature difference of 20 degrees centigrade. Then coefficient of apparent expansion. Here 1 by 50th mass of liquid is expelled from the specific gravity body. See, that's why you have to take here. So the coefficient of apparent expansion is nothing but mass of the liquid expelled, that is 1 by 50th mass. See, original mass of the liquid which is there, m, into change in temperature. What is the change in temperature? The temperature difference is 20. It means that small m get cancelled. So 1 by 50 into 20, 1 by 50 into 20, that becomes 1 by, so 1000. Okay, so that is 10 power minus 3. See, 10 power minus 3 per degree centigrade. In the given options, 10 power minus 3, option C is the correct answer for this question. So you can solve like this. This is a simple explanation for this. The same thing, 10 power minus 3 per degree centigrade. So coming to the next question. The apparent expansion is 50 cc. It is a repeated question actually. Of the liquid is being heated through 20 degrees centigrade. It is found to be 0.5 cc. What is the coefficient of? The coefficient of linear expansion is 0.9 into 10 power minus 5. Coefficient of absolute expansion, real expansion should be find out. So just it is a repeated question. Yeah. The same explanation what it is given. Okay, so mass of liquid 0.5 upon 50 into 20. So that becomes 5 into 10 power minus 4. The small changes are there here. See, the changes are, just now previous slide I told you the similar problem. It is, see, 0.5 upon 50. This is gamma G is equal to 3 alpha. See, gamma R is equal to gamma A plus gamma G. So simplify, you will get 5.27 into 10 power minus 4. Similar to the previous problem. So then next one is variation of density. Variation of density with the temperature. The passage 2. The passage 2 questions, if you observe here, the 28th question, that is the 28th question, if D1 and D2 are the densities of the liquid at temperature T1 and T2, then D1 by D2 is about what? d1 by d2 is equal to what? See the formula here, see d1 equal to, see d is equal to d naught upon 1 plus gamma t, d naught upon 1 plus gamma t. This is the formula. See that formula if you apply, see if you apply that formula, see d1 can be written as d1 is equal to d naught upon 1 plus gamma t1, 1 plus gamma t1. So d2 equal to same model d naught upon 1 plus gamma t2. So now question is d1 upon d2, d1 upon d2. So that becomes, so d naught upon 1 plus gamma t1, d naught upon 1 plus gamma t2. So d naught get cancelled. Then you will get here 1 plus gamma t2 upon 1 plus gamma t1. See this is the answer, 1 plus gamma. See, might have given in the key option A, but it is option C. Option C is the correct answer. See, option C will be the correct answer. 1 plus gamma t2 by 1 plus gamma t1. This will be the correct answer. So coming to the next, that is 29th question. The coefficient of real expansion is 0.2 into 10 power minus 3. The density at 0 degrees centigrade is 10 grams per cc. The density at 100 degrees centigrade is what? See, density at 100 degrees you have to find out. To find out this, see the same formula just now we used. Okay, see the density at d2 equal to d1 plus 1 plus gamma into delta t you can write. So d2 is nothing but here the d2 value, if you try to find out, see d2 equal to d1 1 plus gamma t2 minus t1. Okay, so d1 is 10 grams per cc, 1 plus gamma value 0.2 into 10 power minus 3 into change in temperature 100 minus 0. So simplify this, you will get 1 plus 0.02, that becomes 1.02 into 10. It means the density at 100 degrees centigrade, the density at 100 degrees centigrade is 10.2 grams per cc, 10.2 grams per cc. You can solve like this. See next question, d naught is the density of the liquid at 0 degree centigrade and the coefficient of real expansion is 10 power minus 3, density at 100. Similar model problem. Just okay, so see here if you observe, see d2 equal to d1 into 1 plus gamma into t2 minus t1. So d100 is given, d100 is equal to d naught into 1 plus 10 power minus 3 into 100. So that means, see 10 power minus 3 into 100 is 10 power minus 1, that becomes 1 by 10. So d100 equal to d naught into 1 plus 10 by 1 plus 1 by 10, that is 11 by 10 will come. So d100 is equal to 11 d naught by 100, 11 d naught by 10. So you can solve like this the similar model problem. See next, matrix match type questions. So there are two columns, column 1 questions, there are 4 questions will be there, column 2, so there are, so answers will be there, you have to match this. So gamma g is here, if you observe, see the gamma g value is positive. If gamma g is positive, then the gamma g is less than gamma r. See then which is the correct option? Gamma g is container expansion is less than real expansion. So then the option liquid level first decreases then increases. Liquid level first decreases and increases. Usually the container gets heated first. So due to that liquid level decreases. Then after that liquid starts heating. So then liquid increases its level. So that's why first decreases and increases. If gamma g is negative, then liquid level increases continuously. liquid level continuously it increases. That is the option here. You have to gamma G is equal to gamma R. If gamma G means the container expansion is equal to real expansion, then the liquid level does not change. The liquid level does not change. Then gamma G is greater than gamma R. If gamma G means container expansion is greater than the real expansion, then liquid level decreases. So these are the options you have to take like this. So here the 31 option yes, and 32, see 32, that is option P. See, like that you have to match. 33, that is option P. 32 is P, 33 is just, you have to be careful. 32, yeah, 32 is not P, it is Q. Okay, so Q you have to take. So accordingly you have to match the, okay, so matrix match type. Here only single matching is there. Sometimes more than one correct answer also will be there. Then previous exam questions. Previous exam questions, if you take, see level 3, that is a vessel contains a 1 mole of oxygen, O2. Okay, molar mass is 32. The temperature is T, the pressure is P. An identical vessel containing another helium gas, so which is having so relatively mass 4 at a temperature is 2T. See, the pressure and volumes are same, only temperature is different. So PV by T, okay, according to ideal gas equation. So PV by T is constant. So from that you can find out the pressure. Okay, so initially let us take here. Yeah. So the PV by T, if you take the values, is constant. So for the first case, that is PV only, temperature is T. But the second case, the pressure is P dash. Okay, so see now PV upon T is equal to P dash into V upon temperature is doubled, that is 2T. So from this you can simplify this. VV get cancelled and TT get cancelled. Then pressure P dash equal to 2P. Pressure is 2P. So in the given options, if you observe, see 2P will be there, option C. Option C will be the, okay, so correct answer for that question. See next one, that is which of the following graphs correctly represents the variation of, see V equal to, that is dP, P equal to minus dV upon dP plus V. This is actually, if you observe carefully, it is also something like just here. See, PV is equal to constant. Apply differentiation both sides. Okay, so if you apply differentiation with respect to, so then P dV is plus V dP will come. So that means that equal to 0. If you simplify this graph, you are going to get, it is a, see pressure is inversely proportional to volume, that is rectangular hyperbola you are going to get. See the given options rectangular hyperbola, that is, this is the option A is the correct answer. Option A is the correct answer for this question. So next one, the densities of the liquid at 0 degrees centigrade and 100 degrees centigrade respectively 1.0127 and 1. A specific gravity bottle is fitted with 300 grams of the liquid at 0 degrees centigrade and so up to the brim it's heated 100 degrees, then the mass of the liquid expelled. See, you have to find out the mass of the liquid expelled here. See, from this data, the densities you can find out the real expansion. Then apparent expansion, if you try to find out, you will get this simple solution. If you observe carefully here, see, from this you will get the real expansion. The real expansion of the liquid. The real expansion of the liquid, that is D0 minus D1 by D1 into TT. So the temperature, the density at the 0 degree centigrade is 0.00127. The density at 100 degrees 1.0127. Substitute values 1 minus that 1.027 minus 1, you are going to get the real expansion is 125 into 10 power minus 6. After getting the real expansion, so the apparent expansion is equal to real expansion minus 3 alpha g. alpha G is the container, linear expansion. Okay, so then substitute the values here. So apparent expansion is equal to, if you substitute the values, 125 minus, so the value what it is given, so you are going to get is 98 into 10 power minus 6 per degree centigrade. This is the apparent expansion after substituting the values. See, then this apparent expansion, the mass of liquid expelled, you have to find out. See, we will go to the data, what it is given. See, the coefficient of linear expansion of the glass is 9 into 10 power minus 6. 9 into 10 power minus 6. See, we will try to see alpha value is alpha. Yeah, sorry. See, the alpha value, what it is given. See, the real expansion is what you got, 125 into 10 power minus 6 per degree centigrade. So then gamma G is equal to 3 alpha. So 3 into 9 into 10 power minus 6, that is 27 into 10 power minus 6. See, this is gamma G. Then apparent expansion is equal to real expansion minus, so container expansion. So real expansion is 125 minus 27, so into 10 power minus 6, that becomes, it is 98 into 10 power minus 6 per degree centigrade. So now if you try to find out, see, if you, here there is a, so mistake is there, mass of liquid expelled should be find out. So that is nothing but 98 into 10 power minus 6 equal to mass of liquid expelled divided by mass of the remaining liquid. See, and change in temperature. These two values, if you know, mass of remaining liquid and change in temperature, then we are going to get the value. So to do that, here, yeah, see the mass of remaining liquid, so the densities are there, so that gets heated, the mass of remaining liquid expelled, the mass of liquid expelled you can find out by using that. So it is 1.0127 grams and 300 grams of liquid, it is given 300 grams of the liquid which is there. So that 300 should be taken there, the 300 value should be taken here. If you take 300 for this, and this is 98 into, see the 98 into 10 power minus 6, okay, so that upon 300 into, so change in temperature is 100 degrees, change in temperature is 100, so that becomes 3 3 is 9. So simplify this, okay, sorry, you have to take, yeah, just let me take here, this is apparent expansion, 98 into 10 power minus 6 equal to mass of liquid expelled should be find out upon, so 300 grams into change in temperature is 100. So now try to solve the mass of liquid expelled here. The mass of liquid expelled is, you are going to get here, so 3 into 3 8 ja 27, 3 8 ja 24, 3 9 ja 27, 294 into 10 power minus 2. So simplify, you are going to get the value, okay. So the mass of liquid expelled in terms of that is nothing but approximately, that is 2.94 grams. The 2.94 grams, you are going to get the value, that is 3 by 1.01. Here there is a mistake, the mass of liquid expelled you have to find out, the mass of liquid expelled should be find out, like that you have to solve this problem. See, coming to the next problem, the coefficient of apparent expansion, the coefficient of apparent expansion of liquid when determined by using the two different vessels A and B, gamma 1 and gamma 2 respectively. So the linear expansions are of A is alpha, then coefficient of linear expansion of the vessel B. See, there are two vessels, A and B are the two vessels. Linear expansion is given alpha. So from this you have to find, so the next, the B vessel, what will be the linear expansion. To solve this, see, we have the real expansion is equal to, apparent expansion plus 3 alpha. So gamma 1 plus 3 alpha remains constant, that equal to gamma 2 plus 3 alpha. Apparent expansion of the first liquid is gamma 1, gamma 2 is the apparent expansion of the second liquid, the vessel B. So if you try to find out 3 alpha 1 equal to, so from this gamma 1 minus gamma 2 by 3 plus alpha, gamma 1 minus gamma 2 by 3 plus alpha, you can solve in this manner. See, that is question number 38. Then 39th question. So when liquid in a glass vessel is heated, the apparent expansion is 10.30 into 10 power minus 4. The same liquid is heated in a metallic vessel. First it is heated in the glass vessel, so then it is heated in the metallic vessel. So what will be the coefficient of linear expansion of the metal? Here also similar model problem. If you observe, the apparent expansion plus linear expansion, apparent expansion plus 3 linear expansion, so that is gamma. Okay, see, gamma of apparent expansion plus 3 alpha of the glass, gamma of apparent expansion plus 3 alpha of the metal. If you try to find out, substitute the values and solve the question. So then so 17 into 10 power minus 6 per degree centigrade we are going to get. See, it means that just we will solve here. Yeah. Here actually there is a glass vessel, the glass vessel and a metallic vessel. The glass vessel and metallic vessel is there. Here glass vessel apparent expansion of glass vessel is 10.3 into 10 power minus 4 per degree centigrade. See, the same, this is 10 point metal is, okay, so 10.6 into 10 power minus 4. 10.6 into 10 power minus 4 per degree centigrade. So now you here the coefficient of linear expansion of the glass. What is the coefficient of linear expansion of the glass? The same liquid metallic vessel, the coefficient of linear expansion of the metal, but glass supposed to be given. Glass, the data is missing here. Then the same liquid is heated in the metallic vessel, the linear expansion of the metal. So glass, it is given. Okay, so if you observe here, see, that is nothing but gamma A plus 3 alpha of glass is equal to, so that is gamma A plus 3 alpha of the metal. So just substitute values here, 10.3 into 10 power minus 4 plus 3 alpha of the glass. Alpha of the glass is 9 into 10 power minus 6. Just this explanation only. So now that equal to gamma A, that is 10.6 into 10 power minus 4 plus 3 alpha. You solve this. Okay, so you are going to get here 17 into 10 power minus 6 per degree centigrade. So that you have to add here 10.3, so 0.27, that becomes 10.57 you will get. So 10.57 into 10 power minus 4, 27, 10.57 into 10 power minus 4 minus 10.6, you have to subtract that, then you are going to get the value 17 into 10 power minus 6. So in this way you can solve these problems. Coming to the next question, see, that is the volume of the mercury in the, so the bulb of, here printing mistake, bulb of thermometer. See, the bulb of thermometer, that is 10 power minus 6 volume see of mercury which is present in this volume is measured in 10 power minus 6 meter cubes. The area of cross section of a capillary tube is 2 into 10 power minus square meters. The temperature raised to 100 degrees centigrade, then increase in the mercury level in the column. So to solve this, see here the volume equal to V2 equal to V1 plus 1 plus gamma delta T. Substitute values, the volume is nothing but area into length. So if you use the value, 10 power minus 6 into, see that is 10 power minus 6 is the original volume, and the area into length, into 1 plus 18 into 10 power minus 5 into 100. If you simplify the length, you are going to get 5 meters. But the increase in length, if you try to find out, 5 minus 4.91, that is 0.09 meters of mercury, which is expanded inside the thermometer. So 9 centimeters, that is the answer is 9 centimeters. 9 centimeters is the option C will be the correct answer. So coming to the next question. The next question is, there are two marks of the glass rod 10 centimeter apart. Their distance is 0.08 mm. So when the rod is heated from 0 to 100 degrees centigrade, the flask of the same glass rod at that volume is 1000 cc. Then volume which is to be measured, same formula, just similar to the previous problem. So if you know the value alpha is equal to L2 minus L1 by L1 into T2 minus T1, then from that, once alpha if you get, and you will get the cubical expansion, gamma is equal to 3 alpha, that is 24 into 10 power minus 6. See, after getting that, so you can get the volume of the at a temperature T, that V2 equal to V1 into 1 plus gamma T1, that means 1000 into 1 plus 24 into 10 power minus 6 into 1000, that becomes 1002.4 cc. See, that is the answer here, 1002.4 cc. That is actually, if you observe, the option A is the correct answer. The remaining options are wrong. So in this way, we can solve the problems of toppers 8th class. So this is thermal properties of matter. Thank you very much. Thank you for listening this video. Thank you.